Hello everyone, welcome to my J Physics channel. So here in this video we are going to learn a beautiful connection between torque acting on magnetic dipole along with angular impulse concept. Okay, so first go through the question, read the question and try your side. Okay, and come back for the solution. So there is a triangle loop which is free to rotate about axis O dash, means this is the axis of rotation. Okay, so every terminology in the question of physics is very important. He is suspended in space in which his vertical magnetic field is present. So something like this. Mass and length of each wire has given m and l. So each wire has mass m, length l. There is a EMF source, battery is connected, and uncharged capacitor. Initial charge on the capacitor is 0. Then what is the angular velocity of the loop just after closing the switch? Okay. So let us see how to solve this question. Okay, so first of all try to understand what is happening in the question also. See, as soon as you close the switch, what will happen? There exists some charge flow, because this is simply battery and capacitor combination, no resistance is there. If resistance is there, then it would have been RC circuit, then the charge accumulation of the capacitor will take some time. But in the question nowhere you will see the resistance for the wires. Okay, so then as you close the switch, then what happens? Charge will flow. So then automatically you will get the charge on this plate is negative, minus CV, and this will be plus CV. But this charge acquire doesn't take much time. The time taken by this charge will be very small. That time value we are taking delta t. Okay, so this is the what is that scenario once you close the switch. But the charge flow will contribute some current, right? So there is a current I in the loop. So then as there is a current I in the loop, this is instantaneous current, and this current will stay for very less time. So as the current is there, there exists some magnetic dipole moment for the loop. So as we are taking this is the loop, equilateral triangle. Okay, as exists there is a current I. Then what is the magnetic dipole moment is? Use the right hand rule. If you curl your fingers in anti-clockwise sense, okay, so then you will get the thumb out of the screen. So then m bar will be out of the screen. So please try to understand this diagram, because I'm unable to show in the video here. So just curl your fingers along the anti-clockwise sense. Then thumb will be out of the screen. So magnetic dipole moment will be out of the screen, whereas magnetic field is in the upward sense. This is along the screen, this is along the screen, this is perpendicular to screen, then angle between the m bar and b bar is 90. So then what is the torque acting on the loop? Torque acting on loop, this we know that whenever there is a magnetic dipole moment or magnetic dipole, current carrying closed conductor is kept in magnetic field, it experiences some torque. See, on this we are getting so many questions in the final examinations. So they are frequently asking the magnetic dipole moment related questions. So I advise all the students to go through this topic very carefully. Okay, then torque value is equal to m bar cross b bar. So now we know the magnitude of the torque is equal to mb sin 90, because angle between m bar and b bar is 90. So m value, magnetic dipole moment value, we can write down current into area of loop into magnetic field is B. Current into area of this equilateral triangle, which is root 3 L square by 4. This we know already, half into base into height into B. This is the torque value. But how to write down the current value? Current value we can write down C. As we discussed already, the charge acquired by the capacitor is very quick. It will take very less time, delta t time. So that's why I am writing that charge, instantaneous current I can write down, charge flown CV by delta t time into root 3 L square by 4 into B. So all the terms I am writing as it is. Now here is the interesting task, which is tau into delta t is equal to CV into root 3 L square by 4 into B. Okay. So now what is the torque into time interval will give you angular impulse. Okay. So the linear impulse is force into time. So similarly we have an angular impulse concept also, which will tell you change in angular momentum. Okay, if you want you can write down magnitude. So CV into root 3 L square by 4 into B. So final angular momentum minus initial. So final value is L I am taking. So that means there will be some angular velocity. How it will be? See, m bar is out of the board. It is in this direction, m bar cross b bar. The torque direction you will get something like this. This is the torque direction. If this is the torque direction, the rotation will be in this sense. Then about this axis of rotation, the loop will try to come out of the screen. So try to understand, if I am writing something like this is A, B, C, then C point will try to come out of the what do you say, that screen. See, one has to understand these directions very carefully. In magnetism, you people, students will have most of the times I have seen that students are having the doubts in taking the directions properly. So one has to practice these directions very carefully. Okay, so is equal to CV into, I can write down root 3 L square by 4 into B. Then L value I can write down I omega. Okay, where I stands for moment of inertia. Now I am writing first moment of inertia value. This is an equal triangle. Now this is the axis of rotation. So then this moment of inertia, this rod moment of inertia will be 0. Why? Because it is on the axis. Now we require the moment of inertia of this rod, so which is having the angle 60. When a rod is having the some angle theta with the axis and axis passing through one end of the rod, the moment of inertia we know that ml square by 3 into sine square theta. So if I follow that, that is ml square by 3 into sine square 60. Sine 60 is root 3 by 2, then it is 3 by 4. You will get ml square by 3 into 3 by 4. So you will get ml square by 4. Okay, this is moment of inertia of one rod. So similarly, moment of inertia of other rod also same. This is also having the angle 60. So total moment of inertia of the entire loop I can write down 2 times of ml square by 4. You will get ml square by 2. So then I can write down the angular momentum value. I can write down ml square by 2 into omega. This is the required angular velocity, which is equal to CV into root 3 L square by 4 into B. Then finally omega value I will get 2 cancels out, L square cancel out. Okay. Then root 3 times of CVB by, you will get 2 times of M. So the required answer is root 3 B C V. I wrote V here, voltage or potential difference across the battery, but they have given the epsilon or E. So you can replace the V with E, then it is root 3 BCE by M, 2M, sorry, 2M. Then answer should be what? C. Okay, so for more videos, you follow the channel. So this is the in this channel we are going to upload very good questions. So please follow carefully so that it will be helpful for your examination.